Alright, now we're going to talk about solving rational equations. We're still going to have to deal with domain problems. Remember, the issue is that we can't let the denominator go to 0. So when you first look at an equation, you have to check out all the denominators that have variables. These are the ones we have to be careful for. So we set each denominator to equal 0 that has a variable in it, and we solve those equations. And what we have found is the domain is all real numbers except for, in this case, -1 and -2. So we write that in set notation. Remember, this reads a set of all n such that n cannot equal -2 or -1. Alright, now remember, when we are clearing denominators, we're looking for an LCM, something I can multiply on both sides that will clear denominators. So we go find my unique factors. We have n plus 1, a 2, and n plus 2. We need all factors once, and so that is my LCM, and I'm going to multiply both sides. So this is what we look like. Now remember, this is all one term, where there's two terms inside here, so I'm going to use my distributive law. So when we distributed this on the first term, we notice that our n plus 1 cancels out, and what's left is 2n times the quantity of n plus 2. Now we have our plus sign, and when I multiply this entire thing times the second term, my 2's cancel out, and what's left is plus. I have an n plus 1 and n plus 2 equals. Alright, over here I only have one thing inside my parentheses, so it's just one term. I can cancel, and I'm going to have what's left is a -4 times the quantity of n plus 1. Now notice we no longer have fractions. We use the LCM to multiply both sides to clear denominators. No fractions. Alright, so this is what we've done so far. We worked on our LCM, we determined the denominator, and here's what we worked. So now we're going to have to finish this up, because we notice we have this 2, this n squared, and that tells me I'm going to have to use quadratic techniques, because I have the n squared, so I have to set it equal to 0. I checked to see how to factor this, and it looks like we're going to have to use grouping. So we come over here and we multiply the first term's coefficient times the last term, get our 18, find factors 18, and add to 11. And so we go through the grouping process and we bring it back. And what this implies is either the first factor equals 0 or the second, so we find our two solutions. Of course, we always need to check, but before we do, let's go back to the domain. Okay, we're okay because we didn't come up with a -2 or -1, so these values should be good. We're going to do the checks on the next slide. Okay, so here is. Now notice we are now reviewing complex fractions. I love checks because whatever you've just learned, you're going to be reviewing in your checks in the very next section. So again, we have to come in here. First thing we did is get our 1/3. Now I could use symbol form, and of course I changed that to multiplication, and now it's an order of operation problem, and we come up with -3/2. Here again, complex fraction. We combine those two things. Now notice that I put 2 in as 6/3. Right off the bat, I tried to find what I call a better representation. Over here, instead of 1, I did 3/3, because if n's a -2/3, I knew I was going to have a common denominator, so I sort of saved myself a step. Here, we're ready to go to symbol form, change it to multiplication, cancel, and we are good. Alright, in this one, it's a little bit easier because I don't have complex fractions, just fractions themselves, and so that checks out nicely too. So we found that both of our solutions did work. Alright, let's take this problem. Remember, the very first thing you have to do is to factor our denominators so we can find the unique factors and find our LCM. And so we go through that process. We find our domain, so we check to see t means that t equals 0, t equals 3 would be a problem. And so we find the domain values that we cannot use are 0, 3, and 9. Alright, now we take our LCM and I multiply both sides. Now I only have one thing in here, so I can just cancel, and then I have left 6 times the quantity of t minus 9, 12 times the quantity of t minus 3. Notice that this stays linear. So that means I use linear techniques, which I will simply isolate the variable and find out that t equals -3. Check my domain. Okay, that's a good answer, so it's time to go and check. Alright, so in our check, we put in our -3. This is an order of operation, means that this division is a grouping symbol, so we do our exponents first. Negative times negative goes positive, and it reduces to 1/3. Same thing happens over here, so we're good to go. We're remembering that this was our domain, so is t equals -3 an answer we can use? Yes, it is, and so that's the reason the solution is -3. Alright, solving another one. Let's look at this one. Okay, so unique factors are 3 and n, so LCM happens to be 3n. The domain is, notice the only problem we have is that n can't be 0. So we're ready to multiply both sides. Now I've got two things inside here, so I'm going to do some distributing again. I'm going to do this in my head this time because 3n times n gives me 3n squared. 3n times these, the n's will cancel, they give me a -9. Here my 3's cancel, leaving me 26n. Quadratic, bring everything to the left side, set the right side equal to 0. And we've got to go over here and group it, so we go through the grouping process, bring it back, it implies, and here again, we set both factors equal to 0. We've got two answers, we check up here domain, okay, we're set, ready to go. So, we check. Now here again, we've got this complex fraction, so I had to leave out some steps because of space, so you can go through that. And this one wasn't quite so bad, that was just fractions, and there you go. That's how your homework should look. In your homework, we need all of this stuff. Alright, this is what I did while ago by in my head. And so notice here, it shows the cancellation. This is where the 3n squared, that's where that came from, and that's what we had done mentally in the previous problem. Alright, let's get another one. Look at this guy. Okay, now look at this minus minus here. Now watch carefully. Remember, negative times negative goes positive. Alright, my LCM, I find my unique factors. Let's see, I have an a plus 3, an a minus 1, a 3. I already have that one, already have that one, already have that one. So those are unique, and each one once. The domain, by setting these, the 3 equals 0 doesn't make any difference. Remember, if you've got a constant, you don't have to worry about that. But this would mean that a cannot be -3, and this says a cannot be 1. So we multiply by our LCM. Let's see here. Ooh, lots of good stuff canceled. Here, we still got a 5 times quantity of a plus 3. On this side, 4. Oh, wow, look what happened that quickly. Now we distribute. It's linear. We simply solve for the variable. Let's see, -13. Nope, we're good. And so now we run it through, and here again we'll deal with fractions. The solution set is. This was one we done earlier, but I just wanted to go through it because here's your strategy. Find the LCM means you have to factor all denominators. Find the domain means you set factors equal to 0. Clear denominators means you multiply both sides by LCM. Solve the resulting equation, check your domain, the solution may not be legal, and then you're ready to write a sentence. So that's the strategy for solving a rational equation. And I don't know why this came back. Oh, I guess I just went ahead and put this all on one page, and so there we go. Alright, so that's solving rational equations.